Hello, and in this video we'll be looking at stacks. So the main characteristics of a stack are similar to a queue. A stack is also a linear data structure, which means you have one element followed by another element followed by another one. Its size is also flexible, so you don't need a fixed amount of size allocated beforehand, because the size of the stack increases and decreases as you add and remove elements from the stack. Now, where the stack differs from a queue is that it follows the first in, last out pattern. So if we stack a block one on top of each other, if we want to remove one block off the stack, we would have to remove the last one we added on. Now that we know the characteristics of a stack, let's implement a stack. We'll be using a linked list to implement a stack, so let's create a node class. Now the node holds the data of the element in the stack and a reference to the next element in the stack. And let's create our class stack, which will have an initializer, an isEmpty method, peek method, add method, and a pop method. Now the stack method will have a reference to top, which is the last element added onto that stack, and which will be the first one to be removed as well. Now isEmpty will just check if the stack is empty. Now to do that, we just return the output we get from the self.top and check if it's none. So peek will return the data of the node at the top of the stack. Now if it's an empty queue, top will be a none, which will cause an error. So let's just do if self.top, else we just want to return none. Now let's look at the add method. Actually, let's call this push, because you usually push things onto a stack, pop things off a stack. Now if we want to push an element onto the stack, we have to create a new node and then link the new node to the top of the stack by referencing this node in the new node's next attribute, and then we just change top to be the new node. So let's create new node, pass in data, link the new node to the current top, so next equals self.top, and then set self.top to be the new node. So a stack follows philo, so first in, last out. So this will be the last element to be removed if we want to pop an element off the stack, and this will be the first one off. And to do that, we simply just set top to be the next element in the stack. So let's capture the data of the current top and set top to be the next element in the stack, and then return the captured data. Now if the queue is empty and we call the pop method, we'll get an error because top will be none. So let's just check if the stack is empty, and if it is, return none. So that's the characteristics of a stack and how you can implement it in Python. I hope this video helped, and as always, if you have any questions, leave them down in the comments below, and I'll meet you in the next video.